need to expose image processing capabilities to your AI while keeping the interface clean and self-documenting. You'll see how to create a FastMCP tool that processes images with optional resizing, using Python's type annotations to automatically generate documentation and parameter metadata that AI models can understand. The pattern shows how to combine annotated types with default values to create flexible, well-documented tools that handle both required and optional parameters seamlessly.
From typing, import Annotated. At MCP, tool. Def process image. Image URL. Annotated SDR. URL of the image to process. Resize. Annotated bool. Whether to resize the image, false. Width. Annotated int. Target width in pixels equals 800. Format. Annotated SDR. Output image format equals JPEG. Dict. Process an image with optional resizing. Hash implementation.
This demonstrates the Decorator-driven tool registration pattern, where Python functions become AI-callable endpoints through declarative metadata. The @MCP tool Decorator transforms ordinary functions into typed, self-describing capabilities that LLMs can discover and invoke, while preserving the function's native implementation. What makes this distinctive is the complete separation between your business logic and the RPC infrastructure. You write pure Python, while the framework handles schema generation, validation, and transport. The pattern works by leveraging Python's type system and Decorator introspection to create a bidirectional contract between your code and AI clients. Type annotations define the input-output schema, docstrings provide human-readable descriptions, and the Decorator registers everything with the MCP server at runtime. This creates a clean abstraction where your functions remain framework-agnostic, while gaining network accessibility, parameter validation, and automatic documentation without any boilerplate code. This approach solves the core problem of exposing backend logic to AI systems without coupling your code to specific transport mechanisms. It's particularly valuable for AI agent architectures, where you need to dynamically expose capabilities while maintaining clean separation of concerns. The trade-off is that you must adhere to type annotation discipline, but in return, you get automatic API generation, client SDK compatibility, and the ability to modify tool implementations without breaking client integrations. Let's break it down line by line.
From typing, import Annotated.
Imports Annotated from Python's typing module, enabling metadata attachment to type hints. This powers the tool's parameter descriptions that appear in AI interfaces, making the function self-documenting for both developers and models.
At MCP, tool. Def process image.
The @MCP tool Decorator marks this function as an AI-callable tool in FastMCP. It transforms the Python function into a structured tool with automatic schema generation from type hints and docstrings, enabling AI models to discover and invoke it with validated parameters.
Image URL. Annotated SDR. URL of the image to process.
This uses Python's annotated type to add metadata to the parameter. The string description becomes part of the tool schema, making it self-documenting for AI models and API clients.
Resize. Annotated bool. Whether to resize the image, false.
This defines an optional Boolean parameter with a default value of false. The annotated type hint adds documentation that AI models use to understand the parameter's purpose, while the default prevents callers from needing to specify it.
Width. Annotated int. Target width in pixels equals 800.
This defines an optional parameter with a default value of 800 pixels. The annotated type hint documents the parameter's purpose for both developers and AI tools, while the default eliminates the need for explicit width specification when resizing isn't required. This follows the pattern of sensible defaults for optional processing parameters.
Format, annotated SDR. Output image format equals JPEG.
This defines an optional output format parameter with a default value of JPEG. The annotated type hint provides documentation for AI tools while maintaining the string type, ensuring the parameter is both self-documenting and type-safe. Default parameters like this eliminate boilerplate by handling common cases automatically.
Dict.
This return type annotation declares the function returns a dictionary, defining the output schema for AI tools. FastMCP uses this to validate responses and generate documentation, ensuring consistent structured output for all callers.
Process an image with optional resizing.
This docstring defines the tool's purpose for both developers and AI models. FastMCP uses it to generate the tool's schema and documentation, while also serving as the human-readable description in the API reference.
Hash implementation.
This placeholder marks where the actual image processing logic would implement the function's contract. The implementation would handle downloading from the URL, optional resizing based on parameters, format conversion, and returning structured results, all while maintaining the type hints and docstring promises exposed to AI callers. FastMCP tool schema design. The annotated type hints in at MCP tool decorators create self-documenting schemas that AI models understand, while field constraints enforce validation without runtime overhead. Excluded arguments must have default values. Otherwise, FastMCP raises an error during server initialization. This pattern lets you design tools that are simultaneously strict for machines and intuitive for humans.
The schema that describes everything becomes invisible to the client that understands nothing.